Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. So, for example, to go to the information about seminars, just go to this URL in your browser, type in smarturl.it/btdt-online, and you will see the information. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. Let X be the percentage score on a college entrance exam for students who did not participate in an exam preparation seminar. X is modeled by a uniform distribution on the interval from A to 100. Let Y be the percentage score on a college entrance exam for students who did participate in an exam preparation seminar. Y is modeled by a uniform distribution on the interval from 1.25 times A to 100. It is given that E of x squared, so a second moment of x, is equal to 19,600 divided by 3. Calculate the 80th percentile of Y. And here's the solution. The mean of x is, and let's write mu sub x for it, a plus 100 over 2, the midpoint of the interval on which x has uniform distribution. And the variance of x is sigma x squared equal to 100 minus a squared over 12. That's just the length of the interval on which x has uniform distribution squared divided by 12. And you need to know that that's how you find the mean and variance of uniform distribution. That's something you should know for the test. Therefore, the second moment of x is mu x squared plus sigma x squared. That's another formula that you should be very familiar with for the exam, when you take the exam. Well, that's equal to a plus 100 over 2 squared plus 100 minus a squared over 12. And the first expression can be expanded into a squared plus 200a plus 10,000 over 4. And the second one is 10,000 minus 200a plus a squared over 12. The common denominator is 12, and to get there we need to multiply the top and bottom of the first fraction by 3. So we would end up with 3a squared plus 600a plus 30,000 plus 10,000 minus 200a plus a squared, the whole thing divided by 12. And that's equal to, when we combine the like terms, that's 4a squared plus 400a plus 40,000, the whole thing divided by 12. Well, divide the top and the bottom by 4, and you get a squared plus 100a plus 10,000 over 3. And we know that this is equal to 19,600 over 3. That's the second moment of x. Therefore, a squared plus 100a plus 10,000 must be equal to 19,600. And then we simplify this and we obtain this quadratic equation. So this quadratic equation, a squared plus 100a minus 9600, apologize, I had an a there for a moment, a typo, instead of a squared. That's corrected. And what we have there is a quadratic equation for a. We just solve it using the quadratic formula. A is equal to negative 100 plus minus the square root of 100 squared minus 4 times 1 times negative 9600. And take the square root of all of that divided by 2 times 1. That's negative 100 plus minus 220 over 2. And the two solutions are negative 160 and 60. Only the solution a equals to 60 is feasible. This means that y is uniform on the interval from 1.25a to 100, which is 75 to 100, and its 80th percentile is 95. And you can formally calculated in some way, but you can just note that when moving from 75 to 100, each step of 5 corresponds to 20% probability because it's 5 steps of 5 that you take from 75 to 100, and so each of them is 1/5 of 100% probability or 20% probability. So 80% is reached after 4 steps, and that's 4 times 5 equals 20. So 75 plus 20 equals 95. Answer E. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.